So today we're going to be looking at the review for our Chapter 9 test. We're also going to be using Desmos, so I've already pulled up Desmos at desmos.com/calculator. Remember, when you first open Desmos, it is in radians, and we have to put it in degrees. So that's the first thing we're going to do is go ahead and put Desmos in degrees so that we can actually use it. So for number 1, it asks us to find the value of x and y. Write your answers in simplest radical form when necessary. So notice how number 1 is a 45, 45, 90 triangle. That means that our two legs are the same, and our hypotenuse is the length of the leg times the square root of 2. So since we're already given that one of the legs is 40, we know that the other leg has to be 40 as well. And the rule for 45, 45, 90 triangles is that the hypotenuse is the length of the leg, so 40, times the square root of 2. And so that would be your answer for x and y. On number 2, notice that it's a 30, 60, 90 triangle. So the rule with 30, 60, 90 triangles is 1, 2, square root of 3. And what that means is that the shortest side times 2 is the hypotenuse, and the shortest side times the square root of 3 is the longer leg. So x is equal to 7, because notice how the longer leg is 7 times the square root of 3, and y is 7 times 2, which is 14. Now, for numbers 3, 4, and 5, we're just asked to complete each trigonometric ratio using words. What it's really asking for is just SOHCAHTOA. SOHCAHTOA. So sine of A is opposite over hypotenuse. Cosine of A is adjacent over hypotenuse. And tangent of A is opposite over adjacent. You could write that out in full words. On the test, I believe it's a drop down like it was in the test practice, so it'll have full words there. On number 6 through 8, we're using the right triangle to complete each statement. So notice how each of these uses Q, right? There's no other angles. So I'm going to label this triangle based on Q. I have my hypotenuse, which is always across from that 90-degree angle, my opposite, and my adjacent. So we said in number 3 that sine is opposite over hypotenuse. So for Q, our opposite is 15, our hypotenuse is 17. Cosine in number 4, we said that's adjacent over hypotenuse. So that would be 8 over 17. And finally, tangent number 5 we said was opposite over adjacent. So that's going to be 15 over 8. For 9, 10, and 11, we're looking for the value of x, and these are all side lengths. So we're going to be using our sine, cosine, and tangent, our SOHCAHTOA. So we'll write it again. So to find the value of x here, notice how I'm given the this 57-degree angle. So I'm going to go ahead and label the triangle based on that 57-degree angle. The hypotenuse is directly across from that 90-degree angle. The opposite is directly across from the angle we're given, and the adjacent is right next to that angle that we're given. So since I'm working with opposite and adjacent, I'm going to use tangent because tangent is opposite over adjacent. So the tangent of 57 is our opposite over our adjacent. And we can go ahead and solve that. We're going to start by moving our x out of the denominator, because when x is in the denominator, we can't really solve that way, right? And then we can divide by the tangent of 57 on both sides to get x by itself. So if we're asked for the answer, it would look like this. If we're asked to just set it up, which some of the questions on the test just ask you to set it up, you would do it like that. Number 10, similar, we're given this 56-degree angle. So we're going to go ahead and label the triangle based on that 56-degree angle. And this time, x is our adjacent, and we're given the hypotenuse. So we're going to be working with a trig function that uses adjacent and hypotenuse, which of course is cosine. So the cosine of 56 is equal to our adjacent, which is x, over our hypotenuse, which is 29. And we can solve just by multiplying 29 on both sides. So we get that x is equal to the cosine of 56 times 29, which of course we usually want to write that multiplication in the front. Oh, in number 9, I forgot to go ahead and get our decimal approximation. It doesn't tell us we need it, and on the test you're going to be asked to leave it in the trig function form, but it's good practice, so it's a good thing to do. It also helps you check your work because, of course, we can make sure that, if you're looking for a shorter side, it shouldn't be longer. If you're looking for the hypotenuse, it should be the longest side, all that good stuff. So x for number 9 is approximately 3.25, and x in number 10 is approximately 16.22. Which, yeah, that makes sense. It's smaller than the hypotenuse. Notice that the hypotenuse here is 29. So, yeah, that's good. All right, for number 11, we're given this 13-degree angle, so that's the angle we're going to use. Here's our adjacent, here's our opposite, here's our hypotenuse. We are looking for the opposite, that's where x is, and we're given the hypotenuse. So we're working with opposite and hypotenuse, which of course means we're working with sine. So the sine of 13 is equal to x over 36. We're going to go ahead and multiply by 36 on both sides and find that x is equal to 36 times the sine of 13, which again we can put into decimals to find our decimal approximation. And that is 8.10 would be how we round with that one. Because notice how it's 8.09, but next to the 9 there's an 8, meaning we have to bump that 9 up to a 10, so it's 8.10. For numbers 12 and 13, we're looking to find y, and those are angles, so we're going to need to use our inverse trig functions. So here we're looking to find y. We have our opposite and our hypotenuse, so that means that we're going to be using sine. We know that the sine of y is equal to 12 over 27. So we're going to go ahead and take the inverse sine of both sides, and that'll be the y is equal to the inverse side of 12 over 27. Now in the test, that's how you'll put in your answer, but it's good practice to find the decimal approximation as well. Make sure that makes sense. And that would be 26.39 approximately. And yeah, that makes sense because we should have an acute angle there, smaller than 90 degrees, and we do, so that's good. On number 13, we are given our adjacent and our hypotenuse. So here we're going to use cosine. Cosine of y is equal to our adjacent, which is 7, over our hypotenuse, which is 13. We'll take the inverse cosine of both sides. And just to make sure we're on the right track, we'll go ahead and find our decimal approximation. And that's 57.42. Which, yeah, that makes sense because it should be less than 90 degrees, and it is. So it looks like a good answer there. For numbers 14 through 19, we're solving the triangles, and it's asking for our decimal approximations, okay? So we're going to use our decimal approximations. For number 14, it asks us to start off with h. So I see that I'm given two sides. That means I can use my Pythagorean theorem, because the Pythagorean theorem requires two sides, and then you can use it to find the third. So our Pythagorean theorem says that a squared plus b squared equals c squared, where c is the hypotenuse. So I'm going to go ahead and type that into Desmos, right? So 35 squared plus 37 squared is 2,594. Always good to check if that's going to be a whole number square root. So I'm going to go ahead and take the square root of 2,594. And unfortunately, that's not going to be a whole number square root. That's okay. Since it asks us to round to the nearest tenth, we'll go ahead and do that. So h is 50.9. On number 15, it asks us to find the measure of angle S. So here's S, and if I label this triangle with S in mind, oops, I have my adjacent and my opposite that are given to me. So when we're looking at adjacent and opposite, think of your SOHCAHTOA. SOHCAHTOA. Adjacent and opposite means we're working with tangent. So the tangent of S is equal to our opposite over adjacent, so that would be 35 over 37. We'll go ahead and take the inverse tangent of both sides to find that S is equal to the inverse tangent of 35 over 37. Now, potentially that could be your final answer, but this one does ask us to round to the nearest tenth, so we'll go ahead and put that in on Desmos. And we find that that is 43.4 degrees, roughly. Oh, and I should have used the approximately there as well. Now we're looking at the measure of angle Q. I'm going to switch colors so that we can keep that on here. So let's take a look at the measure of angle Q. So here's Q. Our hypotenuse, of course, stays the same, but our adjacent and our opposite are different. So we're going to be doing this the same way. And we're still using opposite and adjacent because that's the numbers we're given. But it is going to be a little bit different. So we're still going to be using tangent. So the tangent of Q is equal to our opposite, which with Q, that's 37, over our adjacent, which is 35. So we'll go ahead and take the inverse tangent of both sides so that we get Q by itself, and it's equal to the inverse tangent of 37 over 35. So Q is approximately 46.6. And with 17, 18, and 19, we're just working with a different triangle here, but it's the same idea. So first we're looking for the measure of angle T, so this angle here. But notice this time I'm given two of the angles already, so I don't have to use my inverse trig functions. Instead, I'm going to use my triangle sum theorem, which says that if we add up all the angles of a triangle, it has to equal 180. So we'll combine like terms. 90 plus 43 is going to be 133. We'll subtract 133 from both sides and find that the measure of angle T is going to be 47 degrees. Now we've got the measure of angle T, and this one is perfectly equal because there was no decimal to approximate, right? It's equals 47. Done. So we're going to find M and K, which are side lengths. Let's start with M. We're going to work off of this 43-degree angle because that's what we're given. So we're going to go ahead and label our sides: adjacent, opposite, and hypotenuse. So if we're looking to find M, we're given the opposite. M is the adjacent. So whenever we're working with opposite and adjacent, that's tangent. So we're going to use the tangent of 43, which is equal to 15 over M. We're going to have to multiply by M on both sides to get M out of the denominator. And then to get M by itself, we can go ahead and divide by the tangent of 43. So we find that M is equal to 15 over the tangent of 43. And if we put that into our Desmos to get our decimal approximation, we get that M is approximately 16.1. And it makes sense that M should be bigger than our given side because it's across from a bigger angle. So remember that the angles that are across from the sides correspond to the sides, and so your bigger angles should be across from bigger sides. So that makes sense. Now we're going to look for K. K is our hypotenuse. And remember, we're given the opposite. So we're working with opposite and hypotenuse, which of course does mean we're working with sine. So the sine of 43 is going to be equal our opposite, which is 15, over our hypotenuse, which is K. I'm going to multiply by K on both sides to get K out of the denominator. And then we'll go ahead and divide by the sine of 43 on both sides to get K by itself. So really this is the same practice as what we did in number 18, just different numbers. And since it asks us for a decimal approximation, we'll go ahead and put that in our Desmos. And we see that it's about 22, because if we want to round to one decimal place, the 9 would round up, and that would bump the 21 up to 22, and we get that it's approximately 22.0, which, yeah, that makes sense. K is our hypotenuse. It should be our biggest side, and it is, so that's good. In our last question, it says, a man is sitting on the ground and is 30 feet from the base of a tree. All right, so let's draw it. So here's our tree, and here's our dude. He's sitting on the ground. I don't know if that looks like he's sitting or not, but he's supposed to be sitting. And he's 30 feet from the base of the tree. The angle of elevation to the top of the tree is 47 degrees. So that means from the ground to the tree, that's 47 degrees. What is the height of the tree? So we're looking for our height, h. So from this angle that we're given, this 47, the height is our opposite, right? And, oh, such a terrible O. Oh, I guess that'll have to do. And that 30 feet is our adjacent. So we're working with opposite and adjacent, which means we're working with tangent. So the tangent of 47 is equal to our opposite, which is h, that's what we're looking for, over our adjacent, which is 30. We can solve by multiplying 30 on both sides and find that our height is equal to 30 times the tangent of 47, which, if we want our decimal approximation, that is 32.2. And that's it. That's the review.